Hey guys, I want to go ahead and do some more examples using these sum difference formulas. If you see the first one, sine of 35, cosine of 25, hopefully you can recognize it. This is the sine sum, so we're going to add a plus b. So you're going to get sine of 35 plus 25. And that's pretty much it. And then when you add it up together, you're going to get sine of 60 degrees. And then sine of 60 degrees, remember, use your hand. 60 degrees is up here. Sine is the bottom, 3 fingers in the bottom. So the answer is square root of 3 over 2. All right, guys. What about number 2, the second one? If you notice, this is tangent. And for the tangent, all you really got to look at is the top. You see tangent. I know it's going to be a plus b or a minus b. So you notice here's the minus. It's going to be the exact same thing. So tangent is going to be, that's your a, 325. Minus tangent of 100. And then tangent, that's going to give you 225 degrees. Okay, don't really need to look at the bottom. The key is in the top right here. So tangent of 225 degrees, well, if you do your math and you change it into radians, you're going to get 5 pi over 4. Okay? And tangent 225 degrees is the same as 5 pi over 4. Okay, pi over 4, that's your angle that you're looking for, your reference angle. So pi over 4 is this guy here. What's a tangent? Is the sine over the cosine. So root 2 over 2. Okay, square root of 2 over square root of 2. Well, square root of 2 over square root of 2, well, that gives you a 1. Okay, and that's beautiful. That's easy. The only thing is I got to figure out if it's positive 1 or negative 1. Well, 4 plus 1 is going to give you 5 pi over 4. And all sine tacos. Right here, tangent is positive because they're both negative. Over here, negative, negative, right? Negative divided by negative is a positive. So the answer is just positive 1. All right? Hopefully that helps right there. Well, let's do one with radians. Same thing we're looking at here at the top. So this is going to be 2 pi over 3 plus pi over 12. So this is going to be tangent 2 pi over 3 plus pi over 12. Okay? And then so we just got to have the same denominator. So 2 pi over 3 is the same thing as 8 pi over 12 plus pi over 12. Well, that's going to give you 9 pi over 12. So tangent of 9 pi over 12, if you reduce that, if you go ahead and reduce that, you're going to go ahead and get tangent of 3 pi over 4. Okay, which is nice. You're looking at your reference angle, 3 pi over 4. Like we did before, pi over 4, you fold it. And sine divided by cosine. So you're also going to get a 1. But we got to figure out, is it a positive 1 or a negative 1? Okay. Well, pi over 4 is over here. Well, where is 3 pi over 4? Well, 4 take away 1 is over here, 3 pi over 4. And then what do you do now? Well, same thing, all sine tacos. Right here, only sine is positive. That means everything else is negative. So that means this guy's going to be negative 1. All right. Let's go ahead and do some more examples here. This is a good example. I just decided to write it out for you guys. It says write the arc sine of arc tan 1 plus arc sine of x. And it looks kind of hard, but first what you got to do is think about this as your a and then this is your b. Okay, so sine of a times cosine of b plus, and then you switch them, cosine of a times sine of b. So hopefully that just makes sense. That's just from our formula. Now, how do you do this? Arc tan. Now remember, arc, you're looking for the angle. So what you got to do is draw a triangle. All right? So when it says arc tangent, arc cosine, draw your triangle because you're trying to find the angle. And I just called it theta. So you draw your triangle, you draw theta, okay? And then what's tangent? Tangent is opposite over adjacent. Opposite is 1. Adjacent is 1, so this is 1 over 1. And then what you have to do is you have to solve this triangle using the Pythagorean theorem, and that's how you get square root of 2. Okay, same thing with arc sine. Okay, you have to find the angle for sine. In this one I called it beta. Okay, so now what is the definition of sine? opposite over hypotenuse, x over 1. You use your Pythagorean theorem again in order to go ahead and find this third side over here. So now you've solved both triangles. All right, you've solved both of them. So when you have arctan, draw your triangle, put your angle, tangent opposite over adjacent, use the Pythagorean theorem to solve it. Okay, you solve that one. Arc sine of x, you have your beta, draw your triangle, beta, sine is opposite over hypotenuse. Pythagorean theorem to figure out your third side. Now you can go ahead and continue. And what I just did, I just substituted. So arctan, we're actually looking for sine of theta. Okay, and then sine of x is my my beta. Okay, so I just substituted nicely. But what you're gonna do now that you have your triangle, okay, now that you have your triangle, you're gonna find the sine. Okay, now that you have your triangle, now you can find the cosine. Now that you have your triangle here, you can find the cosine of this. Now that you have your triangle here, you can find the sine. Okay, so the first one is sine. We got to find the sine of arctan. So we got to find the sine of this guy. What's the sine? Opposite over hypotenuse, 1 over square root of 2. Good. The next one is cosine, okay, of the sine. So we got to find the cosine of this one. Okay, cosine is adjacent over hypotenuse. Here it is. Okay. The next one, okay, it's plus. You got to find the cosine of the tangent, of the arctangent. Cosine, adjacent over hypotenuse, times. Now the sine of this guy. What's the sine of the sine? Well, the sine is opposite over the hypotenuse. And from then we just go ahead and do our math. Multiply this out, you get the square root of 2 underneath. Multiply this out, you get this guy. Same denominators. Same denominators. You can go ahead and put them together. All right, guys. So that's not too bad. Just make sure with these problems you do have to draw your triangle. All right. Let's go ahead and see if we can do a few more here. We're going to prove this cofunction identity. Remember, a cofunction, that means it comes from the complementary. So the sine of, for example, 60 degrees is equal to the cosine of 30, because 60 and 30 add up to 90. But let's go ahead and use our sum and difference formulas. So this is your A, that's your B. So sine of pi over 2 times cosine of x minus, okay, because it's sine, minus, and then it switches. Cosine of pi over 2 times the sine of x. And we want to see if that's going to give you cosine of x. So all I did here is I just used my formula, my sum formula, and I want to verify if it gives you cosine of x. Well, sine of pi over 2 is actually 1, okay? Now if you remember, where is pi over 2? Pi over 2 is up here, and that point is 0, 1. Okay, what's the sine? Sine is 1. So it'll be 1 times cosine of x minus, what's the cosine of pi over 2? Well, pi over 2 is here, cosine is 0. So that works pretty nicely because this becomes 0. And you can see it does work, it does verify. Lastly, let's go ahead and see if we can do this one. We're going to simplify these. Tangent of theta minus pi. Okay, so this one gets kind of tricky, but you're going to get tangent, just like you see it there, tangent of theta minus, and it's going to be minus also, tangent of pi. That's the top. Then you're going to have to start off with a 1. That's a minus, becomes a plus. And then you just rewrite it. Tangent theta times tangent of pi. Okay? Now we just got to go ahead and do our math. Well, tangent of theta, we're just going to leave it as tangent of theta because we don't know what it is. Now, what is tangent of pi? Well, if you remember, well, where's pi? Pi is over here. Okay? And what's that point? That point is -1, 0. The definition of tangent is sine divided by cosine. So sine is 0, cosine is -1. 0 divided by -1 is 0. So then this guy becomes a 0, which is nice. What about the bottom? We get 1 plus tangent of theta. Okay, what's tangent of pi? We just found that is 0. So this becomes times 0. So 0 times anything is 0. So we end up with tangent of theta over 1, which is tangent of theta. Okay.